Okay, so I just want to briefly walk through this one. So we're saying a student wishing to determine experimentally the acceleration g due to gravity has an apparatus that holds a small steel sphere above a recording plate as shown above. When the sphere is released, a timer automatically begins recording the time of fall. The timer automatically stops when the sphere strikes the recording plate. The student measures the time of the fall for different values of the distance d shown above and records the data in the table below. These data points are also plotted on the graph. So we got this falling this height. We have these data points, and yeah, so what we want to start off with is what seems to be the relationship. So this really looks like one of those quadratic or polynomial or squared relationships that we see. We know that an inverse relationship looks more like that. We know the square root looks more like that. The linear looks straight, but this looks like it's kind of curving upwards. As time is increasing, it looks like our distance starts to increase more. So it looks like we have this squared relationship. So then what we want to do is the student can use these data for distance d and time t to produce a second graph from which the acceleration g due to gravity can be determined. Think about matching up your quantities to your kinematic equations. So if only the variables d and t are used, what quantities should the student graph in order to produce a linear relationship between the two quantities? What is on the vertical axis and what is on the horizontal axis? So this is kind of what we just did, where we said that we wanted to create this, this linear graph. So what we have over here is this d versus t squared relationship. And we really want to figure out some sort of linear relationship. So linear, we know, okay, we have d equals some sort of factor. I'm just going to call it b times t squared. We know that a linear equation looks like y equals like mx. So we can say, well, we need to fit this so that this x is not squared. So we can say, well, say d equals b times t. That looks like it fits up where we have this just standard d, some sort of slope b, and then we have this x, this horizontal axis variable that is just strictly a horizontal axis variable and no squared to it. So we can say that this t is equal to t squared. So what I would want to graph if I was trying to figure this out is on my vertical axis, I would put d. On my y-axis and on my x-axis, I would put t squared, or this big T. So that's on my horizontal axis, t squared, and then my vertical axis, d, and that will give me a linear relationship. Now what I want to do is I want to plot these points so I can figure out, let's see, sketch a graph, we'll plot the data points for the quantities you've identified in part B, and sketch or insert the best fit lines, label your axis, and show the scale you've chosen, and then we want to use the slope to figure out G. So yeah, so what I'm going to do really quickly is I'm going to put these points into Google Sheets, and then I will plot them really quick. Okay.